and welcome back to this series on properties of geometric figures. This one dealing with some quadrilateral stuff, following on from the previous really big video about the different properties of special quadrilaterals. We're going to talk about a couple more properties that quadrilaterals can have, some bits and pieces that become very important, and then we're going to get stuck into some examples. So the first thing I need to talk to you guys about is the idea that you can have convex quadrilaterals, which means that all of our interior angles are less than 180 degrees, but also all of the points or the vertices point outwards. Okay, so that's a convex quadrilateral. All the interior angles, as shown here, are less than 180 degrees. So they're all smaller than 180 degrees. They can be obtuse and they can be acute, but they cannot be reflex angles in this one. And all the vertices point outwards. So nothing points in, everything points out. For non-convex quadrilaterals, we can now have one of the angles being a reflex angle, so greater than 180 degrees. Alright, so greater than 180 degrees. That's our reflex angle. And that particular vertex will be pointing inwards. Alright, so the angle on that reflex angle, or the vertex on the reflex angle, will point inwards. So that's convex and non-convex. Now, issues with the diagonals of those. Convex diagonals will be inside of that figure. Non-convex will have one that is outside of the figure. Okay, you can see there that we have some differences in the types of diagonals. Now, a couple of little points here. The angle sum of a quadrilateral is 360 degrees. I was going to say 180, but that's a triangle. 360 degrees. So if we have our quadrilateral there, you can see down the bottom we've got A, B, C, D. So A plus B plus C plus D means 100 or 360 degrees. So the angle sum of a quadrilateral is 360 degrees. Now the last one there is that if you have at least two parallel sides, you now have some co-interior angles. Alright, so if you have at least one pair of parallel sides, so this is where we've gotten into the trapezium territory, which is the shape that you're seeing there. There will be co-interior angles. Okay, that's it for the actual theory behind quadrilaterals. Let's get stuck into a couple of examples before you get stuck into your questions. Which of the 6 special quadrilaterals definitely have these properties? Diagonals of equal length. Now, we didn't speak about it before, but actually the rectangle is very similar to the square in that the diagonals are now equal. So, diagonals of equal length are the square for sure, and also the rectangle, because we're looking at those 90-degree lines, angles, and coming up with the diagonals through there. Ones that have diagonals that intersect at right angles. Well, the rectangle is now out of that one. They definitely don't intersect at right angles now, but they do intersect and have equal lengths. But in terms of intersecting at right angles, well, we've only got the 3 shapes that do that. So we've got our square, we've got our rhombus, and we've got our kite. Okay, so if you're looking at the diagram from the previous video, that's what you will see. Okay, getting into some calculations now. Find the value of the pronumeral in this quadrilateral, give a reason. Well, sum of the angles in the quadrilateral is 360 degrees. So that's an important one to remember. Sum of the angles in a quadrilateral is 360 degrees. So from that we know that x plus 100 plus 80 plus 110 is 360. If we add all of those numbers up, we get 290. So we've got now x plus 290 is 360. And we also know that if we take 290 away, we're going to get just x, and then we're going to get our answer of 70. So x equals 70 degrees. So that one's a nice straightforward one for us. Don't forget to use your algebra skills in these problems. Okay, last little example. We've got a kite, we've got a trapezium. And we're going to find the value of the pronumerals in these, and then we're going to give a reason for it. So let's look at our kite. Right, well, we've got 60 and 40. Then we've got S, and then we've got the other side. Now, something that's actually kind of cool about kites is that they form 2 isosceles triangles. So if I was to pop the diagonal in, I now have 2 isosceles triangles. That means that those 2 opposite angles there, the S and the one directly opposite, are going to be the exact same size. So when we split them down the middle, it's going to be the same on one side as it is on the other. They're going to be the same. Okay, so that gives us 2S. So this angle here is the same as that angle there. Those angles have to be the same. So that's 2 lots of S. So we now have 2S plus 60 plus 40 equals 360. Now 60 and 40 are 100, so we've got 2S plus 100 equals 360. If we get rid of that 100 by subtracting it, we now have 2S equals 260. One more step to do. We're going to divide by 2 now. And hopefully you are following on with your algebra skills. And S is now going to equal half of 260, which is 130. Okay, and our reason for all of that is we've still got the sum, angle sum of a quadrilateral. Okay. Last problem. We've got a trapezium in our last problem. Alright. Remember what we said before? That when we got parallel lines, like these little puppies, we now have co-interior angles. Okay, so now that we have co-interior angles, we know that these puppies here are the co-interior angles. And we know that they have to add up to 180 degrees. They have to be supplementary. Okay, they have to be supplementary. So, y plus 125 have to equal 180, because that's what supplementary angles are all about, adding up to 180. So again, we use our simple algebra. We get y equals 55. And our reasoning is about that co-interior stuff. So co-interior angles in parallel lines. And that's it. They're the examples for our quadrilaterals and how we're going to work some problems using some of our skills from before and a little bit of algebra. Hopefully this video has been a little bit helpful, has shown you how to do a few things, and good luck with your questions. Thanks for watching.